How are you guys? This video is about real numbers and its subsets. I will define some of these subsets like rational numbers, irrational numbers, and some other definitions. Also, this video will include around 6 questions related to rational numbers and irrational numbers with complete solutions. At the end of the video, you can find 3 practice questions where the answers only are provided. Let's start and see. A real number, as we know, is a number used in our daily life. It can be positive, it can be negative, it can be 0. Any real number can be placed on the number line. And there are subsets. If you need the details of these definitions, you can see algebra course lectures. Also, it is on the same channel in the playlist, algebra course lectures. Now, natural numbers are the numbers we know from 1, 2, 3, 4 until infinity. These numbers, we call them quickly counting numbers. Whole numbers are 0 and the other numbers of the natural. The integers, the negative integers, we have negative integers, positive integers, and we have 0. Note that 0 is not positive, not negative integer. It is an integer, but not positive, not negative. Okay, now rational number. One of the important part about real numbers is rational number. It's integer divided by non-zero integer. So like 2 over 3, 7 over 5, 1 over 10, 0 over 16, all these are rational numbers. Also, rational numbers are decimals that are terminating, like this one, 0.25. See, that's terminating, finishing, which is 1 over 4, or repeating 2.3333 or 2.3 dash. When we write dash on the number, that means it is repeated. The repeated part can be one number, like 33 or 4 or 5 or 6. It can be 2 numbers, like 2.161616, or 3 numbers repeated, or 4. We can have 5, we can have 6. But the important part here is every decimal real number terminating or repeating, we can convert that to fraction. See, like 2.3333 is equal to 7 over 3. Now, to know how to convert these decimals to fractions, you can see the video on converting decimals to fractions. You will find there many examples. Now, the irrational numbers simply are the numbers, real numbers, that are not rational. So the irrational numbers, we cannot write them as quotient of 2 integers. So these are the irrational numbers. They are not repeating and not terminating, like square root of 3. I put here some examples, minus square root of 2, pi, cube root of 2. All these numbers, they are not terminating, not repeating. And we have types of fractions. We have a normal fraction. Fraction represents a part of a whole, like 2 over 3. See, if you have a fraction like this, 2 over 3, we call the number 2, we call it numerator, and the 3, we call it denominator. Sometimes we have a fraction like 17 over 5. I mentioned that down. 17 over 5. We call this improper fraction. Improper fraction, a fraction in which the numerator is greater than the denominator. A mixed number is a whole number plus a fractional part. So 17 over 5, we can write it as 3 and 2/5. So when we have 3 and 2/5, 3 times 5 is 15 plus 2, 17/5. So we call this mixed number. Reciprocal also we have seen before. Definition of a reciprocal. Two numbers whose product is 1 are called reciprocals. Like 4/5. When I say find the reciprocal, it's 5/4. All right. Now also definition of a prime number. Prime number is a number other than 1 that has the factors itself and 1. So this number, these numbers, the prime numbers can be divisible by themselves or by 1. Like 2. See, 2 is the smallest prime number. 2 is a prime number. We can divide 3 by 3, 3 by 1 only. 5 is prime number. 7 is prime. Now, on the other side, we have to know the composite number. Composite number is a positive integer greater than 1 that is not prime. Like 4. See, 4 here is a composite number. 6 is a composite number. 9 also. Why? Why 9 is a composite number? Because 9 can be divided by 9, can be divided by 3, can be divided by 1. So it is not prime. 9 is not a prime. I put here a diagram that will help you to understand the subsets of real numbers. See, on the left side here, we have positive integers and 0, and the negative integers all together will make the integers. All the integers are inside the rational numbers. The rational numbers and the irrational numbers, they make up the real numbers. Just a simple diagram to understand the relation between the subsets. Let's see question number 1. Classify the natural, whole, integer, rational or irrational numbers from this set. We have 1, 2, 3, 4, 5, 6, 7 numbers there. Classify, so make a list and tell me which numbers here inside are natural, which numbers are whole, which numbers are integer, which numbers are rational, which numbers are irrational. You can pause the video if you like, please, for a minute or so, and then make a list and tell me which number is natural, whole, or integer. And then I can show you now on the next slide to compare your answer. Now, I made a nice table here. The natural numbers, where are the natural numbers? See, the natural numbers are only 329. That's one number there, 329. That's a natural number. Now, the whole numbers are 329, also is the whole number, and 0. Because 0/9 is 0, remember. 0/9 is 0. Let's look at the integer. 329 is integer. 0 is integer. Square root of 49, which is 7, is integer. Minus square root of 1 is -1. That's also integer. Now, let's stop and see the rational numbers. What are the rational numbers? Minus 7.655. See, that's rational, terminating. 329, every integer is rational. See, all the integers are rationals. And 0, square root of 49 minus square root of 1. What are the irrational numbers? 8/pi and 6.616207. Not repeating, not terminating. Remember, the last one is tricky. 6.616227, etc. means not repeating, not terminating. Let's see question 2. So simple, so easy, you can answer directly. Is pi equals 22/7? Many math users, many students, they will say yes. And I said in B part, if the answer is no, which number is larger? I think the answer is no. Is pi equals 22/7? No. They are approximately equal. Approximately equal. They are very close to each other, but they are not equal. Let's see. So this is the solution of question number 2. Pi is not equal to 22/7. We know pi 3.14159, and we know pi is irrational. Remember, one simple reason why these are not equal, the pi is irrational, 22/7 is rational. You see, this is from one subset, this is from another subset. If I divide simply here on the right side, 22/7, it becomes 3.1428. So you can see 22/7 is a little greater than or bigger than pi, because pi 3.14159. 22/7 is 3.1428 something. You can continue. Let's see question number 3. I give you another set here. Oh, nice set. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers there. Find the number of the rational numbers. Just tell me the number, count. Say, this is rational, this is rational. Tell me how many. Now look at B part. Find the sum of the rational numbers. So what do you have to do here? I think nice idea here is to pause this video, try to find the rational numbers on your paper, put it aside, write it down, and then add them. Find the sum means add them, and tell me the answer in simple fraction. Like tell me the answer may be 2/7, 1/12, 13/16, something like that. Okay, now since you have finished, let me show you. Now the answer you should get is 13/2. That's the sum. I will explain now in details, but that is the sum. 13/2. Let's see the number here. Find the number of the rational numbers. So the rational numbers, 1, 2, 3, 4, 5, 6, 7. See, they are here. 2.5 is the first one. Minus 12/4, which is -3, 0/5, which is 0, and then minus square root of 49 is -7. This is a little tricky here. Look, there is a little tricky one here. Minus square root of 2, this one is a little tricky. So minus square root of 2 over square root of 18. Look here. Square root of 18, 9 times 2. So square root of 9 will be 3, square root of 2 will be cancelled. So that number is directly minus, you see this number here, it goes here, it's -1/3. And we have the number 10, which is rational, and we have 4.3 dash dash. See 3.333? That will be 13/3. How to convert? Please go to the video, convert decimals to fractions. You will find many examples how to convert 4.3333 into 13/3. Now look here. What do we have here? -3 minus 7 is -10, and 10 they cancel. So I have 5/2 minus 1/3 plus 13/3. Only I have 3 fractions here, guys, to add. So the LCD will be 6. Also, I have another video on adding fractions. Here multiply by 3 up and down, here multiply by 2, here multiply by 2 up and down. The final answer will be 13/2. Nice question, this number 3. Let's see number 4. Given the set H, X, please listen carefully, how do we read this? Set H, X such that X equals n cubed, where n is a natural number. This is H. List the 4 smallest element of the H. See, H has many numbers, infinity. List the 4 smallest elements of the set H. Now, we'll find them now. Then find the sum of all the elements in part A. After you find them, you add them. Please also, if you have time, Try to practice on this. It will give you a lot of information, understanding. So what do? We take the natural numbers. What are the natural numbers? Natural number starts with 1, and then 2, and then 3, and then 4. This is n. So every time I put it here, n, and then I find x. So I find the 4 elements in part A, in the set H. Then I find the sum of all the elements in part A. Please try to find the sum, write it on the paper, then you can check the next slide. The answer should be 100. Did you get 100? Okay, good. Now here I put in details, H, x such that x is equal n cubed. N is 1, 2, 3, 4. Every time I take n, I put it in the equation x equals n cubed. So 1 cubed, 2 cubed, 3 cubed, 4 cubed. You see why cubed? Because it's in the question. Look here, this is the given here, h. X equals n cubed. So you take the natural and then you cube it. So what are the elements in the h? 1, 8, 27, 64. These are the numbers in the h. Now find the sum, just add normal addition. 1, 8, 27, 64, you will get 100. Now let's move to question number 5. Answer to each statement, true or false. Simply read the questions. There are 5 here. Understand, and then please answer it on a piece of paper, true or false. Then you can compare with the next slide. Every natural number is a whole number. If you cannot understand the question or the statement, please go back to the first or second slide and see the definition. Natural numbers are the counting numbers, 1, 2, 3, 4. Every natural is a whole number. Okay. Some rational numbers are irrational. Some rational numbers, not all. Some rational numbers are irrational. Try to think of an example. Can we have some 1 or 2 or 3 or 4 rational numbers that are irrationals? And then we move on to, let's see, number 4. 0 is not a rational number. True or false? Number 5, every rational number has a reciprocal. You know the reciprocal of 7 is 1 over 7, the reciprocal of 2, 1 over 2, the reciprocal of 4, 1 over 4, etc. Let's see the answer here. Every natural number is a whole number. That's true, because 1, 2, 3, 4 are inside the whole numbers. Some rational numbers are irrational. No way. We cannot have any rational number that is irrational. Simple reason, the rational numbers, they can be written as a fraction, a over b, something. Irrationals, we cannot write them as fractions. Every natural number is an integer, yes. All the naturals are inside the integers. 0 is not irrational. 0 is rational, because 0 over 1 is equal to 0. So when I say 0 is not rational, it's false. Every rational number has a reciprocal. No. Every rational number has a reciprocal except 0. See, all the numbers, the rational numbers, they have reciprocals except 0. 1 over 0 is undefined. Okay. Now let's see question number 6, little tricky. Find, which means list or give me or show all the subsets of this set. Set A has elements A, B, C. List them, count them, tell me what are the subsets of this. Suppose A, B, C are 3 students. So what are the small subsets? Did you try? It's not that easy to find all of them. You can find simple subsets like A by itself is a subset, B by itself is a subset, C by itself is a subset, AB is a subset. So try to find all kind of subsets. Altogether you will get 8. Because I listed them here. The subsets are A by itself. Remember, A, you have to put parentheses there. A, B, B is a subset, C is a subset, A, B, A, C, B, C, A, B, C, and then phi. So the empty set always is a subset of any set. So that's why we have 8. 1, 2, 3, 4, 5, 6, 7, 8. Simple way to find it, take the number of elements, ABC. How many elements in ABC? 3. So 2 to the power 3. 2 to the power 3 is 8. Suppose we have A, B, C, D, 4 elements. How many subsets? 2 to the power 4, which means 16. If you have A, B, C, D, E, 5 elements, how many subsets? 2 to the power 5, 32. Now, I'm leaving this as a practice for you. Practice number 1, please. Find the sum of the rational, find the number of irrational. So only the rationals you add them, the irrationals you count them. Number 2, similar to one of the questions there, y is equal x squared minus 1. Find the sum of the elements. Practice number 3, find the product. This is a nice question here. Find the product of the irrational numbers. So you find the irrational on a piece of paper, try to find them, 2, 3, 4, or 5, whatever the number, and then multiply. Product, find the product, multiply. You find the answers of the practice here, 1, 2, 3. Thank you for watching. I hope I can see you in another video with another topic. Thank you very much.